Hello, fourth grade, and welcome to Unit 5, Week 4. Let's get started with our vocabulary words. Your first word is the word mingle. So mingle means to mix together. So either you're talking about mingling in terms of, like, for example, science. So the water molecules mingle with other molecules in the air. They kind of mix together with them. Or you can mingle with your friends. So if you're in the classroom or you're outside, you might mingle with people while you go and you chat with one group for a little while and you go and you talk with another group for a little while. Next, we have the word humid. Humid means when the air feels kind of wet or moist and damp. So when you go outside right after it rains, the air still feels kind of wet and sticky. That's humid. Next, we have the word dissolves. So when something dissolves, it's becoming part of a liquid. So if you've ever seen your parents put, a spoon of sugar into their tea and they mix it around. In the beginning, you see the sugar down at the bottom of the glass. You can still see it like little crystals down there, but as they mix it in the hot tea, that sugar dissolves, right? It melts and it becomes part of the liquid that you put it in. Our next word is the word gritty. Something that's gritty means it's still kind of rough, right? It still has small, hard pieces in it. So something that's got like hard pieces of like sand or stone. So if you've ever seen sandpaper or touched sandpaper, it feels gritty, right? It feels rough and scratchy. Next, we have the word cling. Cling means to stick to something or to like glue to something. So sometimes if you guys have ever played with a balloon, right, and you rub the balloon on your hair or your sweater, it'll cling to whatever it was you were rubbing it on, right? It'll kind of feel like it's stuck to it or glued to it almost. We know that water drops that cling to particles form ice crystals. So a lot of times if it's really cold outside, that's how we get things like snowflakes or icicles. Those water droplets cling or they stick together to make those different things. Our next word is the word typical. Typical means something that's normal. So you can say we have our typical language arts homework out of our practice book every week. So it's something that's normal or something that you expect to happen. It's kind of the same all the time. Next is the word magnify. So when you magnify something, you're making it look bigger than it actually is. So when you use a magnifying glass or you use something like a microscope to see something that's really small and make it look really big, you are trying to magnify it so you can see it more clearly. And again, we have here the word microscope. So microscope is a tool. It's a kind of equipment that we use that has a lens on it that you look through, kind of like a camera, right? You look through the little eye part and you can see things and you can enlarge them or you can magnify them by looking at them through that microscope, make them appear larger than they actually are. Our spelling words for this week are going to be more R-controlled vowel syllables. So we've seen these before. Remember, an R-controlled vowel syllable, it makes the strong R sound. So like the sound a pirate would make, say R. So we have grocer, pepper, barber, grater, polar, tanker, singer, enter, odor, collar, zipper, powder, danger, cheddar, popular, harbor, anchor, elevator, daughter, victor, increase, oatmeal, sleeve, conductor, and waiter. So remember, R-controlled vowels are when you have a vowel followed by the letter R. So A-R, E-R, I-R, O-R, or U-R. Now, for our language arts notes this week, we're going to be doing some review and some new stuff. So it's going to feel like it's longer than usual, but I want to make sure you remember the stuff that we've already learned about in these general areas. So when I give you the new information, you're building on what you already know. So just in case you forgot, we're going to go through and do little reminders before we start each section. So we're going to be talking about antonyms. Now we've talked about synonyms before. Remember, synonyms have the same meaning. Antonyms have the opposite meaning. So if you have the word happy, the antonym would be sad or unhappy. You have the word simple. The antonym might be detailed or complex. Awake, the opposite or antonym of awake is asleep. If you have a part of something, the antonym is the whole thing or the entire thing. Instead of maintaining something, when you maintain something, you keep it the same. The antonym would be to alter it or to change it. The antonym of top is bottom. The antonym of things that are different is the same or identical. The opposite or antonym of general is specific. Or the antonym or opposite of unsteady would be something that's reliable or something that's stable. So synonyms and antonyms don't always need to be just one word. You can have more than one word in them. All right, so we're going to review homophones and frequently misspelled words. So yes, we've talked about these specific ones before. I am going to go over them again because I have seen some of these spelling errors in some of your writing, and they're things that you're going to be using for as long as you read and write. So remember, homophone is made up of two root words. Homo means the same and phone means sound. So homophones are two words that make the same sound. They sound the same, but they have a different spelling and they have a different meaning. So we have there, and there. Their means belongs to them, right? That one is a possessive pronoun. Think of that I as a little person. So this is their house or this is their car. It's the thing that belongs to them. Here means a place and it has the word here in it. So here is right there hidden in the word there. So here and there, we know we're talking about a place, and you can imagine that R kind of like a little arrow that's pointing outwards. So pointing over there. THEY'' we know is a contraction, and we know that ''RE" takes the place of the word are, so they are. You can imagine that that little apostrophe is a little letter A to remind you. Next, we have to, and to. TO means in the direction of something. So I am going to the store, means I'm going in the direction of the store. TOO means a lot or also. So I can say I am too tired, or I want to play that game too. And then we have TWO, which you guys know as the number two. So 1, 2, 3, 4. We also have your and your. So your, YOU''RE, again, is a contraction of the word you and are. So you are a great friend. I hope you are coming with us on the trip. If you're not sure if to use this one or the other one, say it with the words separated. Separate out that contraction. You are a great friend. That makes sense. So we know that we're using the correct one when we use the one with the ''RE. I hope you are coming with us on the trip. That makes sense. Now we also have your, YOUR, which is a possessive pronoun, shows ownership, something that belongs to you. Is your backpack in the classroom? Put on your shoes before you go outside. So a possessive pronoun always comes right before the noun that it's talking about. So your backpack, your shoes. And we have its and its. So ITS is another possessive pronoun. It shows it's something that belongs to it. So this is its toy. The puppy hid the bone in its house. So we're talking about the house that belongs to it, that belongs to the puppy. So remember, noun is immediately after that possessive pronoun. Its IT''S is a contraction of the words it is or it has. So it's going to be cold later this week. It's been a long time since we saw this movie. So again, substitute the whole two words when you're not sure. If it makes sense when you separate it with it is or it has, then you know that you're using the right one. It is going to be cold later this week. That makes sense. Or it has been a long time since we saw this movie. That makes sense. So I know that when I'm using that possessive version, or sorry, the contraction, I know that I'm using the right one because I tried it out with the words separated from each other. And we have a bunch of other homophones and frequently confused words down here. So we have the words through and through. THREW means to throw or to toss something. He threw the ball to his friend. Or we can have through, THROUGH, which means to pass inside of something or to go from one side of it to the other side. So I can say we drove through the long tunnel. We also have week and week. W-E-E-K means the 7 days, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Or it can mean W-E-A-K, which means not strong. So you can say your body felt weak when you were sick. You weren't feeling very strong. Oops, I put this in here twice. So through and through, we already talked about that one. So I'll take that one back out of here. Next, we have the word advice and advise. So advice, A-D-V-I-C-E, is a noun. And it is a helpful suggestion that you make to someone who's dealing with something difficult. So you might say, can you give me some advice on how to train my puppy? Now, when we say advise, sounds like we have a letter Z in it, A-D-V-I-S-E. That is a verb. That's a thing that you do. It's not a noun. So you can say, I will advise my sister on how to take care of her fish. So that is the action of giving that advice. That's the actual doing of it. So that's why that one is a verb. The advice that you give, that's a noun, it's a thing. Next, we have loose and lose. Loose, L-O-O-S-E, makes the S or S sound. L-O-S-E actually makes the Z sound, lose. So loose is the opposite of tight. My shoelaces were loose and I almost tripped. Lose, L-O-S-E, means to have lost something. Be careful you do not lose your new toy. And another one that we've seen plenty of times that gets confused a lot is the word affect and effect. So affect with an A is an action. It's a verb. It means to impact or to change something. The rain will affect our picnic at the beach. That means the rain is going to change our ability to have our picnic at the beach, right? It's going to get water all over everything. It's going to make it very difficult and we might have to go inside. Effect with an E is a noun. It's the result. It's the thing that happened. The effect of the rain was that we all got wet. So the effect was that wetness that we got covered in. We got covered in water. All right, now we have, we're going to be talking about using the words more and most. So we talked about comparative and superlative forms, where we're talking about adding an ER or an EST when we compare something. So remember, we use ER when we compare two things, or EST when we compare three or more things. So fast, faster, fastest. Now, when we're talking about comparative and superlative, we can also use the words more or most. So we use more or most before most adjectives that are two or more syllables long. So the longer adjectives are more difficult to say if you want to throw an ER or an EST on the end of it. So instead we use the word more or most before that adjective. So I don't say this is excitinger than the other thing, or this is the excitingest thing that we've done. I say this is more exciting, or this is the most exciting. I don't say this person is popularer than me, or that is the popularist person in the class. I can say more or most popular. You don't say someone is nervouser than the other person, or they are the nervousest person here. They are more nervous than the other person, or they are the most nervous. Also, same thing. We don't say carefuler or carefulest. We say more careful or most careful. Now, if you have a simple two-syllable word, right? A simple two-syllable adjective that's pretty small, you can still use the ER or the EST. So I still say prettier or prettiest, right? Pretty is a two-syllable word, short. So I can still use the ER or the EST. I can say happier or happiest, uglier or ugliest, hungrier or hungriest. Now, we do not add an ER or an EST if we're already using the words more or most. I don't say this person is more happier than the other person. I say they are more happy or they are happier. I don't say this is the most happiest day. I say this is the most happy day or the happiest day. Now, if you're not sure whether you need to use more or most, or if you can add an ER or an EST, unfortunately, there isn't a solid rule because you see that there are a lot of exceptions. Your best bet here is to check the dictionary. Open it up, check in the dictionary to see how you are supposed to treat that word. Do you add an ER or EST ending, or do you add the words more or most before it? Now, we are going to review combining sentences. Now, there are a lot of different ways to combine sentences that we've learned. We're going to try and compile them this week so that you guys have most of the ways or all the ways that we've talked about so far all in one spot. So when we combine simple sentences into compound sentences, we have to follow a couple rules. We can combine them using coordinating conjunctions, appositives or appositive phrases, adverbs, adjectives, or correlative conjunctions. Now, I know you may not remember what a lot of those things are. This is why I wanted to make sure we did a review first, so that when you get to them and you see them in your work, you remember what these things are. Now, coordinating conjunctions are our fanboys. If you remember what those are, fanboys stands for the word for, and, nor, but, or, yet, and so. So we always put a comma before the coordinating conjunction that we're going to use. So I can say, I want to go to the park. I do not want to go to the store. When I combine those, I can say, I want to go to the park, comma, but I do not want to go to the store. So I have my comma, and then I have my coordinating conjunction right there. And I put, if you scroll down, where's my stuff? Here we go. I put our fanboys farther down so that you can see them nice and big with example sentences about how they're used. You can see that we've got our comma before our coordinating conjunctions for a lot of them, not all of them, but almost all of them, we use the comma first. Okay, so coordinating conjunctions, fanboys. All right, so that means we've gone through this first section. Another way that we can combine sentences is using appositives or appositive phrases. Now, appositives or appositive phrases rename the noun and they describe the noun that comes right before them. So appositives are separated from the rest of the sentence with a comma before and after them. So what it is basically bonus information. It's extra information about your noun that's put into the sentence that if you were to take it out, the sentence still makes sense, right? It's just an extra piece. You already have a whole thought. You already have a whole sentence. You don't need the extra information in there for it to be a complete sentence, but it does give your reader more information about your subject. It tells them more about what you're talking about. So I can have these two sentences. Hermione Granger is accomplished at spells. She is a witch at Hogwarts School, right? Two sentences. I can put them together and use that extra information. I'm putting it in as an appositive phrase where I can say Hermione Granger, comma, a witch at Hogwarts School, comma, is accomplished at spells. Now, the core of my sentence here, the main information is that Hermione Granger is accomplished at spells. But by adding that appositive phrase, a witch at Hogwarts School, we get more information about her. We get bonus info that we didn't have before. Now, another two sentences that I can put together is my childhood friend is Anne Marie. She loved horses. I can put it together by saying my childhood friend, comma, Anne Marie, comma, loved horses. So my core sentence here, the most important bits are my childhood friend loved horses. It works as a sentence on its own. It doesn't need the extra information, but that appositive phrase, which is adding in her name as a proper noun, gives the reader, gives you or me the extra information about the friend. It renames the friend. So instead of saying my childhood friend, now we rename the childhood friend as Anne Marie. We gave you her name. Another example we can do is the dog ran around the backyard. It was a playful pup. So this is one of the examples from your work. Instead, I can say the dog, comma, a playful pup, comma, ran around the backyard. So really, you can say the dog ran around the backyard, and that's a complete sentence by itself. But by adding this appositive phrase, now we're giving more information to our reader about the dog. So those are your appositives and appositive phrases. They give more information. They're separated from the rest of the sentence by a comma before and after them. Next, we're going to talk about combining sentences using adverbs, adjectives, and correlative conjunctions. So an adverb is a word that tells more about the verb, and it almost always ends with an ly. It answers the question how, when, where, how often, in what way. That's what your adverb does. That's its job. So slowly, loudly, carefully, quickly, quietly, sadly, all of these are different adverbs. And like I said, adverbs usually end with an ly. So I can say they read their books, they were quick. I can put that together and say they read their books quickly. If you have a sentence that says she writes, and I can say she writes well. Well is the adverb that's describing her writing. It's telling me how she writes. He will move into his home. He is moving soon. I can put those together and say he will move into his home soon. So soon is describing the when. So that part of the adverb, right? Because we said most adverbs end with an ly, but not all of them. Your adverb's main job is to tell you how, when, where, how often, and in what way something is done. We can also combine sentences with adjectives. So I can say my coat is very warm, it is red. I can combine that and say my red coat is very warm, right? I don't need to make it complicated. I just take the most important bits and I stick them together. So I took the red, that's the adjective in the second sentence, that's describing my coat in the first sentence, and I put it in right before my coat. So my red coat is very warm. And we can also combine sentences by using correlative conjunctions. I know that's a mouthful. Correlative conjunctions are word pairs that are used together to combine sentences. So let's take a look at the graph, or the diagram on the next page first, just to refresh your memory. So correlative conjunctions are pairs of conjunctions that we use in a sentence to join words or groups of words. They're not used to link sentences themselves. They're usually used to link words or something that has similar ideas in them. So we can say both and are conjunctions, either or, just as or so, neither and nor, not only but also, whether or, no sooner or then, if and then, rather and than. These are all different words that are used in combination in a sentence. So I can say, he is neither employed nor looking for a job. That means he doesn't have a job right now and he's not looking for one. This house is both large and cozy, right? So I can say this house is large, this house is cozy. I can put them together using correlative conjunctions and saying this house is both large and cozy. So either and or, either you will eat your dinner or you will go to bed. So let's take a look at the examples we have here. I said we can go to the park or we can go to the beach. And then I can put those together with correlative conjunctions and say we can either go to the park or the beach. Or I can say if we go to the zoo, then we can see the pandas. So those are our correlative conjunctions. So I know it felt like a lot of notes right now. Most of it was review. And I wanted to make sure to put this information all in the same place for you so that when you go back to review, everything is available. Now let's get into our literature anthology, and our first reading for today is an expository text called A Drop of Water. Now remember, expository texts give us information. They have diagrams, they have captions, they have headers, boldface words, all these things that help us to get a better understanding of our reading.
Genre: expository text. Essential question: what can you discover when you look at something closely? Read about water molecules and how they change. A Drop of Water by Walter Wick. Molecules in motion. If a drop of water is added to a jar of still water, and if the water in the jar is not stirred, where will the new drop go? Will it stay near the top or sink to the bottom? A simple experiment reveals the answer. A drop of blue water enters a jar of clear water. It begins to split up. Parts of the drop sink and swirl in different directions. At last, the colored drop breaks into so many parts that it has become part of the whole jar of water. The molecules in a liquid are moving all the time, pushing and pulling each other, attaching to and breaking away from neighboring molecules. The molecules in the blue drop break apart because they are pushed and pulled all over the jar by other water molecules. The energy that keeps the molecules moving is heat. This heat can come from the sun or the room in which the jar is standing. Without heat, water would not remain a liquid. Ice. When water cools, it loses energy. The molecules slow down and eventually stop swirling and pushing each other. When water freezes, the molecules lock together, forming a rigid structure. A drop of blue water no longer moves. The water has changed from a liquid to a solid, ice. Ice is a solid, like metal or rock. But, unlike metal or rock, ice is solid only at temperatures of 32 degrees Fahrenheit, 0 degrees Celsius, or colder. At room temperature, ice melts, changing back to a liquid. Stop and check. Summarize. Explain how ice forms. Include text details. Water vapor. Water always seems to be disappearing. From wet clothes on a line, from puddles on the ground, and from dishes on a draining board. We say it has dried up, but where has the water gone? Just as water can be a liquid or solid, it can also be a gas. The water from the wet dishes evaporates. That is, it turns into a gas called water vapor. Molecule by molecule, the water from the drops on the wet dishes drifts invisibly into the air. Heating water in a kettle speeds evaporation. Heat from the stove makes the water turn to steam, which is extremely hot water vapor. When the steam hits the cooler air, tiny droplets form, and we see a cloud just beyond the kettle's spout. Almost immediately, the droplets evaporate and change back to invisible vapor. Then the water molecules mingle with other molecules that make up air. Condensation. The air around us always contains some water vapor. Water molecules move rapidly through the air and hit everything in their paths. The molecules bounce off most warm surfaces, but stick to surfaces that are cold. In these photographs, molecules of water vapor stick to the coldest part of the glass. Gradually, droplets form on the glass as the molecules accumulate. Water vapor changes from a gas to a liquid. That is, it condenses. Stop and check. Summarize. How does condensation form? Summarize using details from the text. Evaporation versus condensation. In the photographs above, why do the water drops outside this glass disappear, while the drops inside remain? Outside the glass, the water evaporates and spreads throughout the room as vapor. In time, the drops disappear. Inside the glass, water also evaporates, but the vapor is trapped. The air inside the glass becomes humid, which means that the air is full of water vapor. And that vapor condenses back onto the water drops as quickly as water molecules can evaporate. Therefore, the drops remain. Remove the glass, and the vapor expands throughout the room. Evaporation continues, but condensation slows down. In time, the uncovered drops will disappear. How clouds form. Clouds are made of tiny water droplets, too small to be seen without a microscope. If a cloud droplet is to form, water vapor must first condense on a particle of dust. Carried by wind, these dust particles are often bits of pollen, soot, soil, or salt. This experiment shows how cloud droplets form. Salt is placed on a jar lid above a dish of water. A glass cover traps the water vapor. In minutes, the vapor condenses on the salt and coats each grain with water. Hours later, the salt dissolves in the water drops. Clouds form when water evaporates from the Earth's surface and rises into colder air. There, the vapor condenses on cold, airborne particles. More and more molecules cling to the particles until droplets form. It takes about 1 million cloud droplets to make one raindrop. Rain does not taste salty or appear gritty because the particles that allow clouds to form are usually too small to be noticed in raindrops. Snowflakes. This snowflake is shown 60 times its actual size. The angles between the 6 major branches are repeated over and over again in many of the smaller details of this amazing structure. How can such an intricate object form in the sky? Cloud droplets form when water vapor condenses on particles. But in very cold air, water molecules that cling to particles form tiny ice crystals. As more water molecules from the air freeze onto the crystal, they join at angles that allow a 6-sided structure to form. If the crystal grows large enough, it will fall to the ground as a snowflake. Clouds that produce snow often contain both ice crystals and liquid droplets. At the center of this snowflake is a cloud droplet that froze, allowing the snowflake to form around it. Scattered throughout are other cloud droplets that have frozen onto the snowflake as it fell through the cloud. Sometimes snow mixes with pellets of sleet, which are frozen raindrops, like the ones shown below. By contrast, snowflakes are ice crystals that form when water vapor changes directly from a gas to a solid. Sleet, 15 times actual size. Endless variety. Many ice crystals grow into shapes that are just tiny slivers, rods, or clumps of ice. Of these, the underlying 6-sided structure may not always be visible. But when weather conditions are just right, the crystals will grow into an astonishing variety of elaborate 6-sided designs. All the snowflakes on these 2 pages were photographed on the same day. All share the same angles, but vary in design. One has 6 branches of unequal length, giving the appearance of a 3-sided snowflake. Another snowflake has only 4 branches. Apparently, 2 of its branches didn't grow. Odd variations like these are typical. Because different conditions of humidity, wind, and temperature affected the growth of each snowflake as it fell, each design holds secrets of its unique journey to Earth. When a snowflake melts, its intricate design is lost forever in a drop of water. But a snowflake can vanish in another way. It can change directly from ice to vapor. The sequence below shows a single snowflake as it gradually disappears. Snowflakes, actual size. Frost and dew. On some days when the air is humid, a sudden drop in temperature during the night will cause water vapor to condense on cold surfaces. By morning, the landscape is covered in sparkling drops of water, dew. If temperatures fall below freezing, the cold weather relative of dew appears, frost. On windows, frost forms along tiny scratches and other imperfections in the glass. As with snowflakes, frost is the result of water vapor changing from a gas to a solid. That's why the angular structure of ice crystals is evident in the fern-like patterns of frost. When dew forms, a short walk through the grass will soak your feet. On spiderwebs, dewdrops appear like glistening pearls. In the photograph above, we can see how water reflects and bends light. An upside-down landscape appears in each drop of water. Stop and check. Ask and answer questions. How does frost form? Go back to the text to find the answer. Water and light. If you look carefully at this beam of light, you'll see the mysterious way in which light interacts with water. Some of the light is reflected, which means that it bounces off the surface of the water. But some of the light passes into the water. As the light enters the water, molecules bend the light, or refract it. The bent rays of white light are transformed into all the colors of the rainbow. How is this possible? White light is made up of waves of many different sizes, or wavelengths. The shortest wavelength, which we see as violet, bends the most. Red, the longest wavelength, bends the least. All the other colors fall in between. Sun shining on spray from a garden hose creates a rainbow. The spray produces drops of water that bend the light and flash bright colors when seen from the correct angle. Natural rainbows work exactly the same way. The sun must be behind you and low in the sky. The arc of the rainbow is caused by the sun shining on billions of spherical raindrops that fill the sky. The water cycle. The sun's heat and the earth's gravity keep water in constant motion. Water evaporates from puddles, ponds, lakes, and oceans, from plants and trees, and even from your skin. Water vapor moves invisibly through the air, but it is always ready to condense on a cool blade of grass or the surface of a pond. Massive clouds form as vapor condenses on tiny particles of dust in the air. Then, and only then, can water fall from the sky as rain, replenishing lakes, rivers, and oceans. Hard to predict, impossible to control, water cycles around the earth. And water is precious. Without it, not a single living thing could survive. No plants would grow, not even one blade of grass. No animals would roam the earth, not even a spider. But somewhere in the world right now, snow drifts on a mountaintop and rain falls in a valley. And all around us, we are reminded of the never-ending journey of a drop of water. Genre: fantasy. Compare texts. Read about two girls who gain a new perspective as they attempt to save their classmates. The Incredible Shrinking Potion. It began as a simple science project. It was only 1 week ago that Isabel, Mariella, and Hector were working on a shrinking potion that would amaze everyone at the science fair. Mariella and Isabel had perfected the potion, but it was Hector who had created the antidote. Since his discovery, Hector had become less interested in winning the science fair prize and more interested in how this experiment could increase his popularity. His short stature made him practically invisible to everyone at Washington Elementary School. That wasn't the case anymore. Now the entire class was looking up at Hector. He had come to science lab bearing special cupcakes, which made it easy for him to shrink the entire class, including his science teacher, Ms. Sampson. Hector smirked as he placed his miniature classmates inside the tank of Rambo, the class pet. Isabel and Mariella overheard the shrinking shrieks of their classmates outside the classroom door. The girls had been late to lab again. Upon peering inside, they quickly realized they had to do something. Mariella saw that Rambo, outfitted with a vest of tiny tubes, was sniffing merrily outside his tank. "Rambo has the antidote," Mariella whispered to Isabel. "We will have to shrink ourselves to sneak inside and get the antidote. Then we can help everyone out of the tank." With shaking hands, Isabel pulled out a vial. The girls took a deep breath and sipped the shrinking potion. The world around them began to grow. As Isabel and Mariella walked under the classroom door, everything was magnified to the extreme. Desks and chairs towered over them. Even the complex details of each nut and screw became clear, as if viewed under a microscope. The girls made their way to the other side of the lab, dodging mountainous cupcake crumbs and wads of gooey gum. Next, they had to climb up onto the table without being seen. Isabel grabbed onto a wire plugged into an outlet. Hand over hand, she pulled herself forward on the sloped wire until she could see the back of the tank. Then, swinging like an Olympic gymnast, she launched herself onto the table. Isabel stepped along the gritty surface, avoiding wide wooden grooves that she had never noticed before. Feeling lighter than air, she realized that gravity worked very differently at her new size. To Mariella, it seemed a Herculean task to join Isabel on the tabletop. "How did you get up here?" Mariella whispered. "I'll fall if I try to jump." Isabel smiled. "Gravity doesn't work the same way when you're small. If you miss, you can walk up the side like an ant." Swinging with sweaty palms, Mariella launched herself with all of her might. The lack of gravity slowed her, and she felt herself starting to float gently down, 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 just missing the table. Panicking, she lunged forward, using her legs to cling to the wooden leg. "You did it!" shouted Isabel's tiny voice. Her excitement was short-lived, as a humongous hamster cornered her and Mariella. Their even bigger problem, Hector, seemed to realize that something was happening behind the tank. "Quick, grab the antidote," said Mariella. Pulling out a bag of sunflower seeds from her pocket, she offered some to Rambo as Isabel unfastened a vial. She nearly dropped it upon hearing giant footsteps heading her way, followed by her teacher's voice. "You girls are late," Ms. Sampson said as she grasped the vial. Isabel and Mariella breathed a sigh of relief as their teacher took a sip and prepared to put Hector in his place. Mariella grinned at Isabel. "Think our science project will be a big hit after all this?" The tiny friends shared a huge laugh. Make connections. What do Isabel and Mariella discover after they take the shrinking potion? How can taking a closer look at things help people understand the world around them?
All right, that takes us to the end of our stories in our literature anthology. We'll jump into our reading and writing workshop, and we're going to be reading another expository text that's titled Your World Up Close. So remember, some of our words this week were focused on making small things look bigger, so magnify and microscope.
Genre, expository. Your world up close. Compare these gritty grains of sugar with a magnified sugar crystal. Essential question. What can you discover when you look closely at something? Read about a tool that allows us to see everyday objects up close. Does the picture on the left show a diamond or a glass prism? Look closer. Take a step back. You are too close. It is a picture of a sugar crystal. This extreme close-up was taken by an electron microscope, a tool that can magnify an item to thousands of times its actual size. Pictures taken with a high-tech electron microscope are called photomicrographs. The sugar crystal on the left may look huge, but the word micro means small. We are seeing a small part of the sugar crystal up close. Photomicrography dates back to 1840, when a scientist named Alfred Donné first photographed images through a microscope. Around 1852, a German pharmacist made the first version of a camera that took photomicrographs. In 1882, Wilson Snowflake Bentley of Vermont became the first person to use a camera with a built-in microscope to take pictures of snowflakes. His photographs showed that there is no such thing as a typical snowflake. Each is unique. Nowadays, we have electron micrographs. The photographs of Snowflake Bentley showed that snowflakes are shaped like hexagons. The light microscopes you use in school are weak and do not show much detail. An electron microscope is a much more powerful tool, and it allows scientists to see things we can't see with our own eyes, such as skin cells or dust mites. The picture below is a close-up of human skin and shows the detail an electron microscope can capture. The more an image is magnified, the more detail you will see in the photograph. The most magnification that a photomicrograph can capture is about 2 million times the original image size. Magnified images have helped scientists to see what causes diseases. Over the years, scientists have learned how these diseases behave. Looking through microscopes, we have even learned what is inside a cell, or how a snowflake dissolves into a drop of water. This is a human fingerprint, magnified by an electron microscope, times 2 million, times 1 million. Scientists use electron micrographs to see how objects change over time. For example, we can look at a piece of fruit to see how it decays. First, the fruit looks fresh. After a few days, it begins to soften. Then specks of mold appear and cling to it. Days pass, and eventually the fruit is covered in mold. We can see these changes under the microscope far earlier than we can see them with just our eyes. Suppose you mingle outside on a humid day with friends. What would the sweat on your skin look like magnified? The possibilities are endless if you examine your world up close. When the mold on a strawberry is looked at under an electron microscope, it resembles grapes. Make connections. How do electron microscopes help scientists? What objects in your classroom would you like to see under a microscope?
All right, that takes us to the end of our stories for this week. We're going to talk about our comprehension strategy and skill. Now, this week, we're going to focus some more on summarizing. So remember, summarizing is when we take the most important parts of our reading or the most important parts of whatever material we were working with, and that's the part that we share. We're not sharing every single word or every single detail, just the most important parts. We're also going to go over sequencing. Now remember, sequence words you will see in text a lot of times tell you the order that things happen. So when we're talking about sequencing, we're talking about things being put in time order. What happened first, next, then, and then what happened last.
Summarize. To summarize a paragraph or a whole selection, retell the key ideas or details in your own words. Reread Your World Up Close and summarize sections of the text to make sure you understand them. Find text evidence. Reread the fourth paragraph on page 353. Identify and summarize the key details in the paragraph. Photomicrography dates back to 1840, when a scientist named Alfred Donné first photographed images through a microscope. Around 1852, a German pharmacist made the first version of a camera that took photomicrographs. In 1882, Wilson Snowflake Bentley of Vermont became the first person to use a camera with a built-in microscope to take pictures of snowflakes. His photographs showed that there is no such thing as a typical snowflake. Each is unique. Nowadays, we have electron micrographs. In 1882, Wilson Bentley was the first person to get close-up pictures of snowflakes. He used a camera attached to a microscope. His photographs showed each snowflake is unique. Sequence. Authors use text structure to organize information in a nonfiction text. Sequence is one kind of text structure. Authors who use this text structure present information in time order and use words that signal time. Find text evidence. On page 355 of Your World Up Close, I read how fruit decays over time. I will look for signal words, such as first and after. First, the fruit looks fresh. After a few days, it softens and then mold appears. More days go by, and the fruit is covered in mold. Expository text. Your World Up Close is an expository text. Expository text gives facts and information about a topic. Includes text features. Find text evidence. I can tell that Your World Up Close is an expository text. I see headings, photographs, and captions. I also see a series of photos that help me to understand the text better. Text features, photographs, and captions. Photographs help to illustrate information described in the text. Captions explain the pictures and add other important information about the topic. Antonyms. As you read Your World Up Close, you may come across a word that you don't know. Sometimes the author will use an antonym. Another word or phrase that means the opposite of the unfamiliar word. Find text evidence. On page 353 of Your World Up Close, I'm not sure what huge means. I can use the word small to help me figure out what huge means. The sugar crystal on the left may look huge, but the word micro means small. We are seeing a small part of the sugar crystal up close.
All right, that takes us to the end of our notes for this week. If you guys have any questions, definitely let me know. Otherwise, I hope you have an amazing day. Take care. Bye-bye.